All right, so in this video, we're going to go over the vertical line test, okay? We use this test to determine if a curve, okay, even though this is a straight line, we can still refer to this as a curve, okay? It's the graph of an equation, okay? So the vertical line test will tell us if the curve or the graph represents a function, okay? If a vertical line touches the curve more than once, then that equation, the graph of that equation, does not represent a function. Okay? The reason that works, okay, think back to the definition of a function. The definition of a function was where each input, okay, or a relation where each input has one and only one output, okay? A vertical line would have, if it touches the graph multiple times, would have more than one output for each of those inputs, okay? So the vertical line test will tell us if a curve represents a function or not, okay? Once we determine if an equation is a function, if the graph of an equation represents a function, then we're going to determine the domain and the range by looking at the graph, okay? We can tell visually, okay, if this is a function or not, and we can tell visually what the domain and the range is, okay? So let's move on over to the graph and we'll go over these 4 example problems. All right, so let's look at the first problem here, okay? We've got a linear graph here falling from left to right, okay? So let's just draw a few vertical lines just to prove that this is a function, okay? All right, so we've got a vertical line there. That only touches the graph one time. There's another vertical line there in green. That only touches the graph one time, and so on, okay? Now, we could draw any vertical line. Notice that the graph continues all the way down into the right and all the way up into the left. So any vertical line we draw is only going to cross that graph one time, okay? So that means this is a function, okay? So once we've determined it's a function, we need to determine the domain and the range, okay? So like I said earlier, the graph continues left forever, right forever. So that means the domain is going to be all real numbers, okay? Every value of x is represented along this line, okay, along this curve. All right. Now with range, remember we're talking about y values, up and down. All right. So like I said, the graph continues down forever going to the right. It continues up forever going to the left. So just like the domain here, the range is going to be all real numbers. Okay. So that's example 1. So try the next 3 examples. Determine if it's a function using the vertical line test. If it is a function, determine the domain and the range, and then come back and check your work. All right, in example 2, we've got a linear equation that's rising from left to right, okay? So when we draw a couple vertical lines, we notice that each of those vertical lines is only going to touch the graph one time. I'm only going to do 2 because it should be pretty clear by now that all these linear equations with a numeric slope is going to be a function, okay? So the domain, again, is going to be all real numbers, okay? The graph goes forever to the left and forever to the right. The range, even though it's going to take a while, the range is going to be all real numbers as well. If we go far enough to the left, we're eventually going to go down to negative infinity for y. Same thing for going to the right. We're going to go to positive infinity. So all real numbers will be represented for both the domain and the range, okay? Let's look at the third example. All right, so in the third example, again, we're going to look and see, is this a function, okay? So vertical lines, we can draw, again, as many as we want to, okay? Notice that only touches the one time. That vertical line only touches the graph the one time. It really doesn't matter how many of these vertical lines we draw, okay? Notice that any vertical line is only going to touch the function one time, okay? That makes it a function, all right? This is not a parabola. It kind of looks like it might be a parabola, but it's not. We know parabolas have an axis of symmetry, and you can see this is not a symmetric graph. So let's talk about the domain. So if you'll notice, again, these arrowheads, this graph is going to continue forever up and to the right. Okay, over here, the graph is going to continue forever up and to the left. So it continues all the way to the left, it continues all the way to the right, so that means the domain is going to be all real numbers. Okay? Now the range here is a little bit different. You can tell we're just looking at the curve here, okay? This parabolic shaped kind of curve. Again, it's not a parabola, but it kind of looks like it's close to 1. So how far down the y-axis does that graph go? And you'll notice the bottoming out point, the minimum value, to use a more technical term, is right there about -4. Okay, it looks like it might go just below that, but we don't know how far below. So let's just consider that to be a low value of -4, or a minimum value of -4. So when we're writing the range, we're going to say the range starts at -4. Okay, notice we use the bracket there because it includes -4. And we're going to go all the way up. This goes forever up and to the right, forever up and to the left. Okay, so we're going to say that goes all the way to positive infinity. Okay, we always close out our notation with infinity with parentheses. Okay, because infinity is not a real number, so you can't ever be equivalent to infinity. So brackets before the -4 because -4 would be included in the range, parentheses after infinity just because you're supposed to. All right, let's do one more example and then we'll be done. All right, now let's look at the final example here. Okay, we've got a curve in the coordinate plane, so let's see if this passes the vertical line test. So let's say the first vertical line you decide to draw is the green one here. Okay? It looks like it only touches the curve one time, and maybe you wouldn't recognize that it would touch twice, but notice the curve here continues. You see the arrowhead means the curve continues, so eventually it would touch this vertical line a second time. Okay, so we should already be able to tell that this would fail the vertical line test. But let's say you didn't. Let's draw a second vertical line and show clearly that this vertical line touches the curve 2 different times. Okay, so because the vertical line in red touches the curve twice, this curve has failed the vertical line test. Therefore, we don't have a function. Okay. In this exercise, if we don't have a function, the domain and the range are irrelevant because our primary goal right now is to deal with domain and range for functions. Okay, so that's how you use the vertical line test, and that's how you use domain and range with a visual graphical representation to help you out.